Hi, so today in this video we're going to be covering chapter 7.4, which is the multiplication and division of rational functions. Now, I have, as you can see, I have quite a few examples ready to go because this is kind of a tricky one for a lot of people. Now, I don't know if I'll be going through all of the examples, but I just want to make sure we all have about the right idea. Let's just start tackling them. So this first question says, state the restrictions on the variable of the rational expression. Express your answers as integers or fractions in lowest terms. Use a comma to separate multiple answers. So we know restrictions are when the denominator equals 0. We cannot have the denominator equal 0. So what we're going to do is set this equal to 0. We know that if x is positive 6, it's 0. If x is positive 8, the bottom will be 0. If x is positive 2, the bottom will be 0. That's your restrictions. Same for this one. If x is 0, the bottom will be 0. If x is, now we need to, this one's a little harder to tell by our eyes, so we're going to set this equal to 0. So we have negative 7x minus 7 is equal to 0. And then we also have negative 3x minus 4 is equal to 0. Let's start with this one first. We'll add 7 to both sides. So we'll have negative 7x equals positive 7. X is equal to negative 1. So we cannot have x equal to negative 1. And we cannot have x equal to negative 4/3. Because what I did is I added 4 to both sides. So I got negative 3x equals positive 4, divide both sides by negative 3. So we have x is equal to negative 4/3. We can't have either of those. Any of those don't work. And then for this last one, they're kind of being rude to us. We need to find when these equal 0. So first we're going to do x squared minus 1 equals to 0. Now this one's relatively easy because there's no factoring involved. We can just move the 1 over. So we have x squared equals positive 1. The square root of that is going to be x is equal to plus or minus 1. So we know we'll have 1, negative 1. Then we have our 20 x squared plus 3x plus 2. We need to factor this. There's nothing I can take out that's easy. So we're going to do the AC method. That's the way I like the best. So 20 times 2 is 40. We're going to find something that multiplies up to 40. That adds up to 3. Let's think. So I know that 45 and 8. That looks like it will be our best bet. However, this is negative 20. My bad. That makes things easier for us, though. We have a positive 3, so we'll do negative 5. So we'll do negative 20 minus, negative 20x squared minus 5x plus 8x plus 2. Now we can factor by grouping. So negative 5x is times x minus 1, plus 1 in this case, I guess. And then we can take out a 2. So we'll have, this should be 4x. So we can take out a 2 now. So 2 is, and then 4x plus 1. That worked out super nicely for us. So now we have 4x plus 1, and we have negative 5x plus 2. So this is our new denominator. We need to set these equal to 0. So for this one, we'll have 4x is equal to 0. We'll move the 1 over, so negative 1. So we also cannot have negative 1/4. And we also cannot have positive 2/5. If you do the work on this, it will come out to x equals 2/5. We can't have that. So that would be your answer. This unit deals a lot with factoring. So if you're feeling iffy on that, please go back to my factoring videos. They should be in chapter 5 or 4 if I remember correctly. If you go to my 1015 playlist and just like Control F and search for factoring, like either the AC method, it will be listed as I just do method. Just like looking for my factoring things, searching up factoring in there. You want to get really good on that. I will say, for my 1015 students, specifically in my 1015 class, if you are a viewer that's not in my 1015 class, and you know who you are, if you are in my 1015 class, on our final, we will not be focusing all that much on chapter 7 stuff. We will be using a lot of factoring. We will probably be using factoring. I haven't seen the final. This is just what my instructor has told me and you guys. That chapter 7 we don't need to worry too much on. But you do need to worry about factoring. So if you don't have your factoring good, get that down. You can ask me for help, or you can look at some find other resources, whatever works best for you. This one says simplify the expression. And what a lot of students want to do first, and it would technically work for this problem, but it won't work for every problem, is they say, oh, well, here's a 5x. I can go from here and here, right? But that doesn't really work. We need to first sort of factor. So we can take out a 5x squared from both of these. So we'll have 5x squared times 6x minus 5 over 5x squared. Now these can cross out. You can't just cross them out like this. It doesn't work most of the time. So we will have 6x minus 5 for our answer there. Now, another mistake that I see a lot of students doing is they say, oh, there's no denominator here, so there's no restricted values. However, when we're thinking about restrictions, we are thinking about the original graph every single time. Even though this would be perfectly fine to graph, this wouldn't, because we have a hole at x equals 0. So x cannot equal 0. Simplify the expression. We have 9x squared minus 1 and 9x squared plus 6x plus 1. Now, both of these look like perfect. This top looks like a perfect square to me. We have 9x for our a, and then we have a minus 1. So we can do our top. Our top is going to be, we'll write this down here. Our top is going to be 3x plus 1, 3x minus 1. And then our bottom is going to be, I'm going to do the AC method, so 9 times 1 is 9. Factors are 3 and 3. That looks like it'll work for 6. We'll do 9x squared plus 3x plus 3x plus 1. Take out a 3x from this one, so 3x, x plus 3x plus 1. And then this one we'll just take out a 1 because everything's looking good, so 3x plus 1. Looks like we've got two 3x plus 1s. It was probably one of those really nice factoring ones I just didn't know right off the bat. Let me read that. Did I do something wrong? 1 minute. No, looks okay. Looks okay to me. So we have 3x plus 1 and 3x plus 1. Now we can cross one of these out. We can't cross both. So what we're left with is 3x minus 1 over 3x plus 1. Now, with this, we want to look at our original graph when we're thinking about restrictions, but lucky for us, our original graph, both of them are going to be 3x plus 1 on the bottom, so we'll only have one restricted value, which is going to be negative 1/3. So x cannot equal negative 1/3, and I found that by setting the bottom equal to 0. Simplify the rational expression. We're going to do some more factoring. So x, I'll do the AC method for the top, which is going to be 1 times 12, which is 12. We want 2 and 6, no, 3 and 4, that works. So we'll do hippo butts for this. The top is going to be x plus 3, x plus 4, and our bottom looks like a perfect square to me, so we're going to do x plus 4 and x minus 4. So we can cross these guys out, and that leaves us with x plus 3 over x minus 4. Again, I'm moving really quickly because I assume that you have knowledge of how to factor. If you don't, please go check out those videos or study up on it. Basically, you need to know a lot of that for this chapter. It says state the restricted values. Again, we're going to be looking at our original graph. So we both cannot have positive 4, but we also can't have negative 4 because of our original graph. So 4 and negative 4 are not answers. They are going to be our restrictions. Now we want to multiply the following expression. We have 5x to the 8th times 21y to the 6th, 14y 9, 11x to the 5th. Now, I'm hoping from elementary school you learned how to do cross multiplication. If you don't remember how, let me give you a little brush up. If you have something like 3 over, say, 15, and then, well, actually, let's go with like 7, and then multiplied by 14 over like 9. What you can do is you can do a little x and say, okay, can 7 and 14 reduce? 7 goes into 14 one time, leaving you with a 2, right? Can 3 and 9 reduce? 3 goes into 9 one time, and leaving you with a 3. So we're allowed to do that. The same principle applies here. While f well, 5 doesn't go into 11. X to the 8th and x to the 5th can reduce. So what we can do here is so this leaves us with, hold on, I'm suddenly blanking. We can cross these x's out, sort of. So we have 5x to the 3rd times, and then something over 11. And then for this one, 14 and 21 don't go into each other, but we have a y to the 9th and a y to the 6th. So we'll have 21 and then no y because that gets eaten up. And then 14 y to the 3rd. And then we just kind of combine them. We do that. 5 times 21 is equal to 105, I believe. And 14 times 11 is, let me pick my little calculator up because I don't remember off the top of my head. Hold on. 14 times 11 is 154 y cubed, and this keeps the x cubed as well. Yes, that would be your answer. The reason why I want you to do that is because we start moving into some more complicated ones up ahead. Now we want to factor this top. We want to multiply these, but to do that, to be able to do our cross multiplication, it's going to be really nice if we can factor the top. So and the problems that you'll see will usually be really nice to help you out with that. So we have this, and then the top is going to be minus 5, x squared minus 5x plus 4. We'll do hippo butts. We add it to 4 and 1. We'll do negative 4, negative 1. So the top is going to be x minus 4, x minus 1. So multiplication, division, x plus 1. So x plus 3 and x plus 1 can't go into each other, but x minus 4 can. So we'll get rid of this, leaving us with x plus 3 times x minus 1 over x plus 1. I don't believe it wants you to multiply out. Our restrictions are going to be from our original graph, so minus 4 and plus 1. So positive 4 and negative 1. And our new simplified form is going to be x plus 3, x minus 1, x plus 1. Yep, easy. Well, I say easy, but it's hard if you don't have as much practice. So I recommend practicing. This one says multiply and simplify the following expression. Let me see. I'm going to skip this one and move on to one of the more hard ones, just for the sake of time. I know we're all... I accidentally stopped recording on my video, so I'm back. I don't remember what my last words were, but it's basically I'm moving on to a harder one. So we have two different functions, f of x and g of x, and we want to multiply them together. So we have, and this one is going to be putting our factoring to the test, just to the max. So we have, let's look at the first one. We have x squared plus 2x minus 15. Let's try hippo butts. It's really nice that they gave us all just 1x ones. So 1 times negative 15 is negative 15. Factors of that are going to be 3 and 5. That looks like our best bet. We'll do negative 3. So one of our tops is going to be x minus 3 and x minus plus 5. And then let's look at this one now. We've gotten that one taken care of. We have x squared minus 3x minus 4, negative 4, 4 and 1, negative 4. Our new top for this is going to be x minus 4 and x plus 1. If you are confused by what I'm doing, I recommend you go back to look at the factoring videos. I know I keep saying that. It's very important that you know. So we got that one taken care of. So now we can look at x squared plus 6x plus 5. We can do AC method. So 5, it looks like 5 and 1 are going to be our best bets. So x plus 5 and x plus 1. And then the last one is going to be x squared minus x minus 6. So negative 6. 2 and 3. Looks like negative 3 is our best bet here. So x plus 2, x plus 3, minus 3. Whew. Now, I did that super lightning fast. If you are not accustomed to factoring, this unit is really great practice for you because there is just going to be a lot of factoring. Luckily, they were nice to us and were giving us the hippo butts route, but I don't know if it will always be that nice to you. Hopefully it will. I doubt it will be anything crazier on the final. Now we can do cross multiplication. We've got an x plus 1 on this top and this bottom. We've got an x minus 3 on this and this. We know that x plus 5 divided by x plus 5 is just 1. And that leaves us with x minus 4 over x plus 2. That was crazy. That was crazy, crazy, crazy. So x plus 4 and x plus 2. That was a lot of work for just one little point. But it was important because we know factoring. And then the restrictions, we look at our original graph. We know that x cannot equal negative 5. It can't equal negative 1. It can't equal negative 2. And it can't equal positive 3. So negative 5, negative 1, negative 2, positive 3. Crazy, crazy, crazy. Now, we're going back to one of the more simple ones. But the thing that people usually trip up on this, which is a little bit surprising to me, but it's okay, everyone starts somewhere, is they don't know what to do with this division sign. But it's literally everything that we've done with fractions before. So we have 3 times x to the 9th times 35y to the 7th divided by, but when you're multiplying or dividing, when you're dividing fractions, you copy the first part and then you copy dot flip. So 14y cubed goes on the top now, and 11x to the 5th goes on the bottom. Now you can cross multiply. So it looks like we will be left with 3 x to the 4th times, so 3 times 14, which is not coming to my head at this moment, so one moment. So 42x to the 4th. Divide by, now we can, so we got rid of this, and then the y cubed. 35 times 11 is 385. So we have 385y to the 4th. Gross, gross, gross. But you got to get accustomed to seeing those gross, gross, gross answers, because that is how it goes sometimes when you get into higher level math. Whew, last problem. Let's take a deep breath. I was talking like 30 miles per minute. Oh, and it's only, I was going to say it's only been 5 minutes, but I forgot I had the whole portion that I accidentally stopped recording on too. So it's going to be a long video, and I'm sorry about that. Anyway, this is our last one. We're dividing, and it's really, this looks like very intimidating to a lot of people because, number one, we have to factor 4 different polynomials, and not all of them are going to be nice and easy with hippo butts. Number 2, we have division. That usually trips students up. Wait, are we on 3? Number 3, this domain is not what we're used to seeing a lot of times. However, one step at a time. There's that one awesome song in that one Christmas special with like the stop motion. It's like put one foot in front of the other.
Put one foot in front of the other, and soon you'll be walking across the floor.
That one. We're going to do that. We're putting one foot in front of the other. Let's start with this. We have 5x squared plus 8x minus 4. We're going to do the AC method. 5 times negative 4 is negative 20. We want it to add up to 8. I'm thinking that 10 and 2 are going to be our lucky ticket, and we want it to be positive 8. Wait, not 10 and 8. Sorry, 10 and 2. So we're going to make that 2 negative. So 5x squared plus 10x minus 2x minus 4. Now we can factor by grouping. 5x is x plus 2, and then take out a negative 2, x plus 2. So our top for this one, drum roll, is going to be 5x minus 2 and x plus 2. Awesome. So we've gotten this guy taken care of. Now we can put the other foot forward, and soon we'll be moving out the door. So 5x squared plus 6x minus 8. We're going to factor by grouping again. So 5 times negative 8 is negative 40. What multiplies up to 40? That adds up to 6. Let's think. I know that 20 and 2, let's think. 10 and 4, that's probably our lucky number. And we want it to be positive 6, so we'll make the 4 negative. So we have 5x squared plus 10x minus 4x minus 8. Now we can factor by grouping. We'll take out a 5x. So 5x, x plus 2x minus 4x plus 2. Sorry, this should not be plus 2x, just plus 2. And then drum roll, please, for our bottom factors. It will be 5x minus 4 multiplied by negative 4. Nope, sorry. X plus 2. Awesome. We've gotten that one taken care of. We've got our f of x. Now we're dividing. So divided by, let me move these guys up a bit. Or over, I guess it's probably easier to work up. We're doing it. We're doing so good. I'm very proud if you're following along even, because this is probably boring to you. Next, we'll do the 5x one. So we have 5x squared minus 27x plus 10. We'll do the AC method, so 50. We want something that multiplies up to 50. That gives us, that adds up to 27. This one's going to be a little trickier. Probably it's going to be 25 and 2. And both of them are going to be negative. So we'll have 5x squared minus 25x minus 2x plus 10. Now we can factor by grouping. Take out the 5x. That'll leave us with x minus 5. And then we can take out a negative 2, which will leave us with x minus 5. And our top for this part will be 5x minus 2 times x minus 5. One more, come on, we can do it. Let me move this to the side again. Okay, we got that top one. We got that one good and done. Last guy to work on, we have x squared minus 8x plus 15. We can do the AC method. So we have 1 times 15, which is 15. This can be 3 and 5. That looks like our lucky number. So we'll do negative 3, negative 5. We have a coefficient of 1, so it's our lucky day. We can do hippo butts, x minus 3, x plus, minus 5. Okay. Does it feel good? Does it feel bad? Are you having a good time? Are you crying? I don't know. It was a lot of work, but we got through that part. Now, let's move this little guy up a bit. When we are dividing fractions, firstly, give me a minute to think, because I don't remember if x can be 0 here. I don't think it, we'll cross that bridge when we get to it. Okay, so I'll double check when I can. So we'll do copy.flip. So what we're going to do is we're going to keep this guy. We're going to copy, and I'm going to literally copy it because I do not want to rewrite that whole thing. And then we're going to flip. So dot flip. So x minus 3, x minus 5, and 5x minus 2, x minus 5. Now, let's look for commonalities. We've got a 5x minus 2 here. And I'm getting nervous. We can cross these guys out. We can cross these guys out. So now we have, drum roll please, x minus 3 divided by 5x minus 4. Wow, yippee, we did it. That is our simplified version. But we are not done yet. Unfortunately, we are not done yet. But I know you guys love me and you want to stick with me and hear my little 12-year-old voice. We'll put this guy here. Let's take a deep breath before we continue. Okay, so with this, my guess is that we need to find these. We need to find this. My guess would be that x cannot equal negative 2, x cannot equal positive 3, x cannot equal 5, and x probably cannot equal 4/5. But I'm going to check in Lumen because I am not 100% confident on that, and I just want to be very sure. Hold on, let me open that up. Okay, so negative 2, 3, 5, 4/5. Let's try that. Okay, yeah. And then, let's try this. X minus 3, well, first we want this, over 5x minus 4. Okay, I see how it's going. I see what it wants. Maybe. I have one more solution I need. Let me think about it for a minute. Come on. Probably it's gonna be this. One sec. It looks like we also have a 2 over 5 restriction. Okay, yeah. Oh, okay. Now, this one tricked me even. So while I was right that these 4 are restrictions, we cannot have these because we cannot divide by 0. We also, when we copy dot flip, we still cannot divide by 0. So both this top and these bottoms cannot be 0. So when we both have an x minus 5, if these were different, then it would be, we'd have to have one more 0. But this x minus 3 causes a problem too, because this was on the, this 5x minus 2 causes problems too, because it's on the bottom still. So what I needed to do was solve for 0 there. So I had 5x equals positive 2, divide by 2, we get x is equal to 2/5. And that was one of our zeros as well. Whew, that's what you need to write. All you need to write are those in this slot right here. And then, of course, your simplified expression. Wow. Yes, that was a very hard one. But if you can do that, you can do anything. I believe in you. Yeah, have a good one. If you have any questions, please let me know. If I went too fast or if you want more examples, also let me know. Yeah, have a good one.